Our fifth speaker out of 6 is Dr. Roger Pielke, Professor of Environmental Studies at the University of Colorado in Boulder. Let's welcome Dr. Pielke.
Thank you. No one likes to be introduced as the 5th speaker.
Sorry.
It's been a long night, and I'm going to apologize. I'm going to give kind of an academic talk to you this evening. I'm going to present what I'm calling the simple math of emissions reductions. This is going to be kind of a big picture talk about the challenge that we face in reducing emissions of carbon dioxide. And a lot of the discussion is untouched by actual numbers. And if you know a little bit of addition and a little bit of multiplication, hopefully by the end of this short presentation, you'll understand why it is so difficult to actually reduce emissions and why policymakers are struggling with this as we go forward. So I'm introducing this little mnemonic here. 4 lines. People engage in economic activity that uses energy from carbon-emitting generation. Each of these 4 lines in this short sentence refers to a variable. This sentence is all you need to know to understand emissions reductions policies. So here's the little mnemonic. It's related to a number of variables: population, wealth, which is expressed as GDP per capita, using energy. This is a term called energy intensity of the economy, which I'll define a little bit more precisely, and then carbon emitting generation, which is carbon intensity of energy. We can express these simply as variables. TE is total energy over GDP. GDP is economic activity. C over TE is carbon emitted per unit of energy. And this results in something that's called the Kaya identity. This is just an identity, but it breaks down emissions into the various factors that conspire together to lead to emissions. And you can simply cross out units and see, yes, carbon equals carbon. This is the Kaya identity, and if you understand this, you understand the entire closed circle of emissions. Now, what this slide shows is how we can turn the various factors in this identity into a discussion of policies and the different levers that policymakers have. I'm going to start by telling you there's only 4 levers, and in a moment I'm going to tell you there's not even that many. Population. We could, all else being equals, if there's less people, there'd be less emissions. Smaller economy, as we're seen in the last 18 months, if there's an economic slump or recession, that has effects on emissions, but the approach to policy would be, all else being equal, limiting generation of wealth. We could improve efficiency, which means doing the same or more with less energy. Or we could switch energy sources, which means generating energy with less emissions. That's it. These are all of the tools in the toolbox. And I'm going to simplify things. If we just combine population and per capita wealth, that's just GDP. That's economic activity. And if we combine carbon intensity and energy intensity, that's carbon emissions per unit of GDP. And I'm going to call that technology. That's the use of technology and also the tools of technology together. These are the only 2 tools in the toolbox that we have. I'm going to make things even more simple. This is from a newspaper article. There's a lot of them around these days. But I'm going to posit, and since I don't have a lot of time, I am going to posit it. In my class up in Boulder, we discussed this at length. But that as an active strategy of reducing emissions, limiting the generation of wealth, or actively trying to reduce GDP is just not going to happen. It's not a tool in the policymakers' toolbox. In fact, policymakers around the world are doing everything they can to kickstart economic growth. This graph, which I'll just discuss briefly, also explains why this is the case. I'll just show you the top half. I'll talk about the top half, which is a density function, so it shows the proportion of people at different income levels. And so as you go from your left to your right on this graph, that's higher levels of income. So the blue bell curve, that's the OECD country, that's the rich countries. But most people are underneath the peak of that curve, and they're fairly poor. They're in Africa and Southeast Asia. 80% of the world is to the left of where this arrow is. And I would argue that development policy is probably going to continue trying to push the shape of this curve to the right. Regardless of what happens to the folks in the blue curve, that's us, progress will be measured by, for example, the number of people living on less than $1 a day. If we reduce that number, we think we're doing good. People who like to discuss, do we consume too much? Have we attained too much wealth? It's a worthy conversation to have, and I talk a lot with my students about it, but I'll point out that most of the academics are way out on the right, and that's where we can have that discussion. If everyone on this curve was out there, we could have that discussion. So the point of this is that reducing GDP is not something policymakers are going to be actively pursuing. That leaves us with technology. To underscore this point, you can just have a look at the text there, and I'll describe it. Gwyn Prinz, a colleague of mine at the London School of Economics, attended the preparatory meetings for the G8 summit in 2008, and he pointed out what he called a glorious incoherence, that in the morning session, policymakers were talking about the problems associated with the high cost of oil, and they had to bring it down. They broke for lunch, they had champagne and caviar, they regathered, and then they explained that their next challenge was to raise the price of oil to deal with the carbon dioxide problem, recognizing that these issues are in conflict. I say that policymakers are conflicted, but they're not confused. When GDP comes up against emissions reductions, in every case, GDP is going to win. So this gives us a problem in the policy of emissions reductions because, so here we have the Kaya identity. Emissions result from combination of GDP and technology. And if GDP must increase, because this is, at least in the short term, the policies that decision makers are focused on, and GDP beats emissions, then you can see from this equation that emissions are going to go up because GDP must go up. So I'm going to use the magic of mathematics to get us focused on what we really should be focused on, which is advancing technology, which I'm going to use this term called decarbonization. And I'll define that here very precisely. The numbers I'm going to use as I go through some graphs are gigatons of carbon dioxide per $1,000 of GDP. So decarbonization of the economy is reflected in a decrease in the ratio of carbon dioxide to GDP. And so here's 2006 numbers, which are the last numbers for which data is reliably available around the world. And there's about 29 gigatons of carbon dioxide emitted and $47 trillion of global GDP. And that gives us this ratio of 0.62 tons of CO2 per $1,000 of GDP. Now we can ask the question, how low does this ratio have to get in order to meet the targets that policymakers are talking about? So the targets are associated with, say, a 450 parts per million level, if that means something to you. Some talk about a 350 level. Others talk about a 2-degree temperature target or an 80% reduction in overall global emissions. Let me tell you that my talk is not dependent on reaching agreement on what that target actually is. What I'm going to use in my slides are targets established by national governments and internationally, but they're consistent with the idea of an 80% global reduction in emissions from 1990 levels by 2050. But again, the scale of the challenge is not going to be too sensitive on what that endpoint is, as you'll see. So here's some good news. This may be the last good news of the talk. The global economy has been decarbonizing. It has been for about 100 years. We've become more efficient in our use of energy, and we're relying on less carbon-intensive fuels. At the end of this curve, you see a little bit of a flattening out, which is an important part of the story, but some of the work has been done for us. So here's that 0.62 tons of CO2 per $1,000 GDP in 2006. Now, this graph simply shows a scatter plot of GDP and CO2. And if you had thought that the world is breaking this connection through policies, the answer is that the world is not. This relationship isn't one-to-one, but it's pretty close to one-to-one. Our global economy runs on fossil fuels that emit carbon dioxide. That's an annoying reality, to use the term from